folders aside the download. We're going to be installing Ubuntu 20.4 LTS in VirtualBox, long-term support LTS, that's what it means. Go on Google and type Ubuntu. Make sure you're in Google where you have the Ubuntu website and click on downloads. It opens up. Yeah, the desktop version is what we want. So we'll click on that, and then it takes us to where we have the ISO file, which is the actual software. Take a very good look at the system requirements. Make sure your computer exceeds or meets these requirements. We will not use a USB or a DVD, so don't worry about that. So let's click on that. Forget about signing up for anything. Just wait for it to download. So open up VirtualBox. Now in the new tab, yes, the new tab, click on that. Put your name or whatever name you want to put, and then look for the newly downloaded file. All this is sped up in this video, but because the file is about 6 gigabytes, so it will take a good while. This whole tutorial will take about an hour plus to install. Click on next. Here you have your username and password. Ensure you change the username from Devops user. If you want to keep it, you can keep it, right? And then put a new password. But remember these info because you'll need it to log in. Here we need your processor. You can make it 2-core, and you leave your memory the same. Then your disk, leave it at the same. And this is a summary of everything. Click finish and wait for your Ubuntu operating system to begin the installation process. So this whole installation will take not less than an hour, but I'm just speeding everything up. So from here on, it's going to take a while to load, to download, install files, packages. You just have to be patient. Okay. You have to be patient here. Just ensure you have enough memory allocation and CPU core so that it won't fail. The installation will not fail. So it's good to leave your memory, the default memory it's allocated to you, but the CPU you can move it to 2-core or more depending on the spec of your processor. So Ubuntu is a Linux flavor. It's about the most widely used Linux flavor. You've got Red Hat, you've got all the other types. Okay, installation done. And the operating system is booting up. So you have to give it some time to boot up. Okay, we are done. Remember the username you've entered at the beginning. Put your password. Ensure it's a correct password and hit enter on your keyboard.
Are you overwhelmed with identity management in the context of omnipresent threats to your organization?
Hi, so no one knows what that means.
What's happening?
Just explain how Okta helps secure digital identity. Keep it simple.
Like what?
Like when delivering a fresh uniform. Or viewing your results. Yeah, it's that. Or making Brad swoon at the high school reunion.
Oh, I love that color. Phew, that was a lot.
Oh, there's more. Like, lots more.
I have the craziest story time to tell you guys. I just got home. Lunatic. I don't know what's sauce on my food. From Bulldog. Bulldog. My goodness. Yeah.
Oh my God! Look who I'm here with. I'm with all.
Underneath all the heel deep in it from the get-go. They keep running all that, You know everything wanna be, Yeah, hold up high key. They seem to turn it up and now when we on the scene, all about the let's go.
Ain't that fly, turning up the flame, about to jump into the bag, ain't coming back. I say that, they say to turn it up and now when we on the scene, all about the let's go, get it down for all that, You know what it is, Every time I hit it where I'm at, it's living back beginning.
So these you just skip all these. Next, skip, just click next, next. Click that tab at the bottom and search for terminal. Double click on terminal. So we are here on terminal, but if you look, it's so small. Don't upgrade, just cancel the upgrade. Go to view and click on scaled mode and switch. So now we have a bigger terminal view. Okay. Our package manager. If you have this error, I'll show you the first solution. There are two solutions. So the first one is to use this command. Enter your password, the one you use to log into this operating system, and then once you're done, you use this command that you're seeing there with your username that you specified at the beginning. Basically, this is it. You can now log out. And that's one way to do this. So the second solution is to go into the vsudo file, go to your root and type that command and scroll down to, I'll put a red rectangle to show you where you need to make changes. Yes, exactly there. Put your name, the name you used to log in, and then space, and every other thing you see on top, just type the same thing, and then you close this page. I'm going to put the command to close from this page. I'll send it to you so you will see. So these are the two solutions. We exit and then we come back to update our package manager, and you see it will run. Put your password, and that's it. So a lot of these installation process was sped up. Just be ready to go through these. Just prepare at least 2 hours aside the download stage of the installation file. If there are any issues during your installation, don't forget to reach out to me in our Telegram group, and we'll sort it out. But if you are going to be good in DevOps or cloud, you need to learn this stuff. So the package manager is done. Thank you for getting this far. You'll do well as we proceed. Let me stretch the screen a little bit with the training. Goodbye, and see you in the next lab. Now this installation, we're going to be installing Visual Studio Code and VS Code for short. As usual, go to your Google and in the browser type Visual Studio Code, and then make sure you are in the actual website, and then click the download link. So it takes you to Visual Studio Code website. We are dealing with Windows, so click the blue rectangle Windows for Windows 10 and 11. And then we wait for it to download. Okay, so we use Visual Studio Code to, it's like an all-in-one application that helps you. It has terminals for you to be able to access your operating system. You can write code, you can write scripts, you can write technical documentation, right? It's called an IDE. IDE is called, it means Integrated Development Environment. We're going to look at, how to work with Visual Studio Code also. So you can, it's a multi-purpose application. So ensure that you follow the process. It may be a little different from in your computer, but by and large the options are still the same. And if you have any issues, let me know. Reach out to me in the Telegram group, and I'll take you through to solve the problem. I think we're about done with the download process. Okay, so we are done. The download is complete. Okay, so we double click on that, close the window, and then we agree to the terms and just click next, next, next. We select that option to leave it on our desktop. Next, install. So this is one of the easiest installations we'll go through. I think so far the most difficult of them will be Ubuntu, and it's also the most lengthy of all. So we are good to go with Visual Studio Code, and let's click finish and it will launch. There you have it. This is the integrated development environment, the IDE, Visual Studio Code. So I hope you like this tutorial. I'll see you in the next lab. This lab, we're going to go on Google to learn how to install Git in our local computer, right? So that's what we want to do. So type Git in your Google browser and hit enter, and make sure you are with the one that has git-scm.com. Go to the downloads for Windows, or we are dealing with Windows installation here, and under there you will see the 32-bit under standalone installer. Don't use that one, use the 64-bit Git for Windows setup. Yes, that's the one, because most of your computers will be 64-bit. So we'll wait for it to download. We're going to be looking at Git in detail in one of the classes. We might take about 2 or 3 days to look at Git, but okay, so the download is done. I want us to basically get all these installations behind us. So we can now double click on Git and straightforward, just click next, next. You don't need to do much. Next, 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 next. Click next. Let's look at that. Yeah, we'll leave it. We'll use it for third party also. So we'll click next here, and yes, we'll leave it for OpenSSH. We will click next. We'll also click next. Most of these parameters, you just leave them as default and click next, next, next. Same thing, and we'll click finish, install. So Git installation is very simple and straightforward, but your Windows environment may be different from mine. I use a Windows 11, but by and large, the installation process is still the same. You're going to still encounter the same questions, parameters, and options. If you run into any issues, don't fail to drop a comment in the Telegram channel, and we will handle it. But I want us to all finish this stuff before we start the training, so that everybody is is ahead of the installation process. So do well to follow up and ensure you complete every one of the installation that we're doing. All right, so we should be done with installation of Git. Okay, let's engage. Let's check launch Git bash and deselect the second one. Deselect this one. Yeah. Click finish. So we have Git bash running in our system. It's just a terminal, right? So we can start checking files and whatnot. So thank you for watching. Okay, so this is how to install Git in the VirtualBox environment. You just use sudo apt install and then space git and -y, and that's all you just need to do. Enter your password and you log in, and then Git is installed. It's a pretty straightforward process. It doesn't last. This whole lab for Git will shouldn't take more than 5 minutes, and you are done. After this, we are going to confirm that Git has been installed. Okay, so let's confirm that Git has been installed. So I'll just let you know, test. To confirm Git installation. Right, that's all I want to do here. So what we'll do is to type Git in space no Git space -- version. All right, that's it there. Git version 2.25.1. So here you go. Git has been successfully installed. Thank you very much for joining this lab. Okay, so I'll type it. Thank you for watching. I'll see you in the next lab. This will be an installation of Mobile STEM. If you want to use another sort of an IDE, but it's not really an IDE, right? Go on Google, type Mobile STEM in your browser, and let's download it. It's also a very good terminal for Windows users. So you click on Mobile STEM and show you're in the right link, using the right link. And then let's take the home edition, the free one. Click on download. And let's use the previous stable edition. That's the portable version 24. Let's click on that and wait for it to download. So Mobile STEM is like the new application that you can use to log into your remote server. Previously, a lot of people were using PuTTY, but Mobile STEM makes it easier for that to happen. So we're going to look at each and every one of these applications we're installing to ensure you understand why we are installing them, and what use they are for. The download is completed. We can close that terminal. We'll go straight to where we've downloaded it. Double click to get the file out. Right, the Mobile STEM file we can now extract. When you double click, it will show you the option to extract. So click on extract, and it extracts the actual application. And then when you double click on that, the application opens up. So pretty simple installation and setup process. So here you go. This is Mobile STEM. You have the light view or the dark view or the dark mode. I prefer the dark mode, so I'm going to use that. And you can create a new session, right? And choose either SSH or use your shell, right? Any one of the options that suits your project you use. But we are also going to look at the way we can use these various options. But now it's just installation, right? That's what we're interested in. Okay, so we'll close that, and we'll just allow this option. So we are in the Mobile STEM terminal, and this is just another option to VS Code, to Git Bash, to your PowerShell in your Windows. Thank you for watching. See you in the next.
So just before we continue, just another note. After we finish each session, the videos will take time for it to process, and then it will land in my Google Drive. What I'll do is I'll upload it in my YouTube so you can go there and view it. The best you can do for me is to like, to subscribe, make comments, right? I mean, that doesn't cost anything, but it helps me. Okay, so I would appeal for you to do that for me. Okay, so I've started recording, yeah. So let me share my screen. back to, okay, let's pull it out. Just a minute. I have so many YouTube channels, so let me just get to the, don't worry, I'll share that one, right? I think you can find it from my Telegram group. If you're in the Telegram group, what I'll do is right now, I will post any of the videos in my Telegram group. From there, you'll be able to get to my YouTube page. Let's see, let's copy link here. Okay, so that's one of the videos that that you can use. Okay, so let's go ahead here. So by now you can all see my screen. So if you can see the screen, right, you can make a comment and just tell me, yes, you can see my screen. Great, 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 great. Great, thank you very much. Okay, so now looking at the software development life cycle, this is what happens, right? I missed one arrow there. You see, you start from the planning stage. The guy brings the idea to you, and then the team assembles, they plan, right? They define all the standards and all the the elements, the things that are required to be in that in that product, right? And it moves to the, once that is concluded, it moves to the design stage. And from the design, let's try on here. Okay, from the design, once the design is perfect, everything looks good, then the developers will come in and start building according to the design. The design is made according to the definition of all the standards and requirements, and definition of standards and requirements is arrived at based on the idea that is given to the architects to draw to what they have written down, what has been communicated to them. So once it's been built, right, the coders build it, it moves on to the next stage where it is tested, right, and then it is deployed. And after deployment, maybe they were not sure that a lot of people are going to like it, and a lot of people are liking this product, but they are saying, I wish the color is the color. I wish you have this button here and all that. I wish you put a like, an emoji, option for us and all that. So it comes back to the planning stage. They define the standards, they design it, they build it again. This time it will be like modifying or amending or updating or upgrading, right? And then they test it, it looks good, and then they deploy. And it comes to the public. And the public just comes on up one day and they see that, oh, a new version is out and it has what they've been asking for. So this is most likely what you'll be expecting in your workplace. I mean, you would find tech is very wide. So you're going to find this happening in various sectors, in the society. So there are, I put here, there are various stages of a typical software life cycle, development life cycle, which I just showed you, those various stages, right? The planning, I just explained what that is, right? The defining of requirements and all that stuff, the designing of the product, architecture, the building, and all. So I'll stop sharing on that. So basically, after the building, the testing of the product, the deployment, right? And then we start maintaining the product. So as a cloud or a DevOps engineer, you can work in any of these areas from throughout the software development life cycle. You could be working in the testing department, you could be, which is like the quality department. You test for quality, you test for security, you test for code integrity and all these bugs, loopholes, and all that. You could be in that department. You could test. You could be at the where they design, at the design stage. It could be where the product has been pushed out to the public, and you are just maintaining the product, checking how the product is performing and all that. So it is important for you to know this background. This is like the beginning of, what happens, what leads to how DevOps and all that came to materialize. Okay, so we have various models. We have the waterfall model, which was the previous traditional model that has been always used, right? And I think that's the one I'm going to talk about. We also have the iterative model. We have the spiral model of software development lifecycle. We have the V model. We have the Big Bang. We have the Agile. We have the rapid model. In fact, there are so many, right? So many. Okay, so but we are going to just look at the waterfall model and the and the agile model. Okay, so let's put a context to this thing. Let's say a company like let's say Sea Ocean wants to build a web application. The name of the company is Sea Ocean, and they want to build a web application that enables it to promote and sell its online product, okay, or sell its products online. And then it approaches you, an IT firm, right? And that builds softwares for companies, right? So they hire you, right? The question now is, how will you handle this project from start to finish, right? So that's why I'm talking about the various software development lifecycle models. There are a number of models, approaches you can take, okay? And it's not good for you to just jump into cloud or DevOps by just going straight to Linux, learning this, learning that, and you don't have any proper background, okay? It's not good. We're even going to computing basics. One of the classes, maybe the next one, we're going to look at computing basics, studying what RAM is, what your storage is, different types of storages, what your processor is, how the processor and the RAM works. These things are critical to you when you start working as the very servers you are seeing in the cloud that you are going to provision, right? Provision means, is a term. Provision means to, it's just like you have a computer, turn your computer on and launch an application and it starts working, right? That's what provision means. So those servers, a server is a computer that contains an application that is being presented as a business product, right? So that's a server. It contains an application, or it hosts an application, right? And it serves other computers. So when you come into your phone and you're accessing Telegram, you're actually accessing your phone is the client. Your phone is being served by the server that holds Telegram. Telegram is residing inside one computer in the cloud somewhere, and you are hooked up to that computer that hosts that application. And from there, you create your account, you do everything that you're doing. So that's what a server is. That mother computer that holds the main business logic that you are hooking up to, right? So that's what it is. So now, whatever you are going to be servers, you are going to be provision have identical or near identical structures like your physical computer. So that's why we need to look at the structure of a physical computer, so that if in case you are brand new, because I know there are some people who already know this stuff, but we have to be patient with people who know absolutely nothing about it, right? So that they can have a good foundation. As we move forward, you start discovering some of these things that I'm saying. You start seeing them, on the like AWS cloud, right? You start seeing those things there. Okay, so yeah. Now a number of ways I was talking about, you know, this company wanting to build a product and bringing it to you as a software development company. So how would you handle it? So let's look at the waterfall model, right? It's a model that is linear in nature. I'll share my screen here. Okay, Olabotu Johnson. Johnson raised his hand. Let's see. Oh, you lowered your hand? Okay, it's okay. It's okay. Okay. So now I'll share. Let's see. Okay, let's use a Microsoft Word so that at least we can make some progress there. Okay. So now the waterfall model, it follows it's a linear model. That is, it goes from top down, from top to bottom. That's the approach. Okay. And one of the things about it is that every phase, every step of that model, every phase must be completed. That is, you must complete step one, complete step one before you move to step two. You cannot skip step one and jump to step three. You must finish step two before you go to step three, right? So the waterfall model is a project management model, right, that is applied in the tech space. So think of DevOps and cloud like as project management, cultures, right? What you are doing, you are managing something. Okay, so that's the philosophy behind it. So now the waterfall model works. Let's draw something here. So the waterfall model starts with the first step, and then you finish it, you come down again, like that. Right? So step one, step two, step three, step four, and just like that. Okay? So that's how the waterfall model, that's how it is modeled. That's how it is, right? And at the beginning, we have what we call requirement analysis. That is, we gather information from the client and all that. And then you cannot do that step before you get to system design, which is the next step, right? Putting together everything that you have gathered, the requirements that the client wants. You put all of them together, you move on to the next step, you implement, right? By writing a set of codes, building your code and all that, right? In accordance with the system design plan. And then you test. Once you have built your code, you start testing your code to make sure that everything works well. And then you move on, you are satisfied with the testing, you move on to deployment. Deployment means to launch it, right? Just like the product that you've made, you launch the product, okay, and it comes out, it comes to the public for them to start buying. So that's deployment. Okay, and then from deployment, the moment you deploy it, you switch to the maintenance mode, monitoring or maintenance mode. Okay, now this waterfall model has issues. It is the traditional model. This is the way people have always, built it. It has issues. I want to try and, get this. Okay, so it is time consuming, right? You have to finish stage one first. You cannot just jump. You have to finish stage one. Each phase must be completed. There's no dodging, no, skipping of any stage, right? Another thing is that there is minimal customer involvement. That is, the customer does not even know what you are doing. You are just, once you start, you get his brief, and you start from stage one here. That's it. The customer doesn't know what you are doing anymore, right? So it takes time because you have to be sure that this stage one is actually perfect before you move here. If not, you have issues. And when you have issues, you have to come back here again. Okay? And then from there, right, the customer knows nothing else that's going on. He doesn't, not sure if you've actually, there's such a thing as we know as what I ordered versus what I got. It might end up like that. You're right. You have something great in your mind, but by the time you see the product, you are wondering, what is this? So that's a disadvantage of the waterfall model for a large project. Look at a project like Facebook, projects like that, like Instagram. These are big projects, right? You can't use this waterfall model. You need, to constantly be sure of what you are doing, right? So you can't use this model because at every point in time, you must be in just one phase. You cannot be in phase one, phase two, phase three, and you must just be in one phase. So you can't. It's not appropriate for large because it will take forever. If you have a very large project, for you to just conclude only phase one, it will take months, right? And who is going to be paying the designers? You're going to be paying them, right? One thing again about this model is that the developers, when it gets to their turn to develop, let's say this is the planning stage, and then the design stage, and then they move from here to development before they go to testing. The developers and the production team, they have nothing in common. They don't see eye to eye. They will never see themselves, right? The production team, they don't know what is going on here in the development phase because they are not connected, okay? And there's nothing like, there's no real-time tracking. There's no way you can know, you can track in real time what is going on in this management model, in this waterfall model. And then if there is anything that is wrong, maybe there are issues that are found as they were developing and building the code, it's very difficult to make changes because you have to come back to step one, phase one, and start looking for a way to avoid that very issue that you found out when it was in the development stage, right? So it's difficult to make modifications, right? And you cannot have any iterations throughout until you get to the product out into the market. Iteration is a term also in tech, which means like repetition or checking. Like, let's give you an example. Maybe it's like a security man, right? A night watchman that circles around a property, right? His job description is that if I give you this job, every night you must circle around the house to make sure no stranger comes around, right? To ensure that everything in that property is safe. So what the security man will do every night is to divide the probably 6 hours from 12 to 6. Every hour he will make rounds. That one round he will go around is called an iteration. You will move around completely, right? So here in the waterfall model, one iteration is moving from step 1 to the finish line and coming back. You cannot do that, right? You have to finish, right? You cannot not just circle, go to the end and view the finished product, right? And come back again. You can't do that because once you are done with phase 1, that's it. You can access it again. Phase 2, once you are done with it, that's it. Phase 3, once you're done with it, that's it. The development team, they don't even know what is happening here. So they cannot come back and say, by the time you are getting to the testing stage, the development guys have been relieved of their job. Their job is done. Their contract is ended. It's gone, right? And then when they discover that the product is being tested and there are issues, they may hire 1 or 2 to come back who may not even be part of the team. So it's just difficult, right? So it's not a project. It's not a model that it works for other kinds of products that may not be tech-based. It works. It's still a viable model. Even some tech models, it still works. It depends on the experience, right? And the kind of product that is being built. You can still use it, right? The experience of those who are working on that project. But by and large, that's not really what we are looking at. Okay, so I'll show you the waterfall. Let me show you just a description of what it is here. So you can see, right? This is how the waterfall model, this is what it is, okay? From the requirement analysis, we come to system design, we come to implementation, which is actually building the code, we come to testing the code, we come to deployment, we come to maintenance. If you look at this, you'll see that it's exactly the way you have. Let's scroll up. When I was showing you your software development lifecycle, it's still the same thing, right? It's an SDLC. It's just that that one now is modeled in a different way. Okay, you see that? So if you don't finish this step, you cannot come here, right? So this is the waterfall model. Okay, so I want to also show you another model, which is basically the one that another disadvantage of this waterfall model, just to let you know, is there is a lot of bickering back and forth. You could have a product that is not well built, right? Or it's well built but cannot be run, monitored well or maintained. And you have the dev team and the production team, fighting one another. No, you didn't show me this, or oh, you didn't do that. You didn't. Everybody, there's always blame game, associated with that particular model. I just want to move down. I don't want to bore you guys with so much. Straight to the other model, which is the agile model. So now, the agile model is a great modification of what all most of the other models are, right? So it's a combination of iterative and incremental process models. Okay, that's a big jargon that I just said there. So let me break that down. Okay, The agile model, the way it works, right, is that it breaks down those steps that you saw into, micro steps, smaller steps, right? That's one of the things it does. It still maintains the elements of a software development life cycle. It still has planning, you still requirement analysis, design, the coding, the testing, and and all that. It still has all those things. Okay, but then each of those steps, each of those elements are micromanaged. They are broken down into microservices, smaller services, right? So what I will do is I'll see if I don't know how I can blow this one up, but let me see. Okay, so I've exhausted. Let's see if I can. Okay, I can't. Let's see. Let's copy this. I'll paste it in Microsoft Word. Let's see if that will work. Okay, so it works here. Okay, so I'll share this now, so you can see this. Okay, so if you notice that you see the word iteration, you can understand what that means now. Okay, circling through a particular system. So now, this is the agile method. Okay, if you notice, it still carries the same of the software development life cycle, right? But then every one of these elements, right, there is a cycling through these elements as you are building. It's not like the waterfall where you must finish this first, right? As planning is going on, analysis is going on, they're designing, they're building, they're testing, like that. It's just a continuous process, right? But the problem with the agile method is that the agile method is not automated. It's still manual. Everything is still from one phase to the other, from one phase to the other. But it's just in a better way. It's better. It's just that it's still, you still have to finish it still has to be done manually. Okay, so that is where DevOps comes in. So DevOps is like when you have like, how will I put it now? Okay, you are cooking it, you're preparing a food, a meal, and then you prepare the meal. The meal is, everything is correct, but then the meal doesn't have salt. So when you taste it, you see that it's not really properly seasoned. So when people eat it, you find that everybody's looking for salt. I mean, just give me a pinch of salt here and there. Okay, so that's what DevOps is on top Agile. It's like the icing of the cake. So what DevOps brings to Agile is automation. It helps Agile to become an automotive SDLC. Okay, right? It becomes automotive. That's like Agile now. These various iterations, right, are now automated. So if you are a DevOps engineer, that's your core responsibility. And guess what? Whatever software development lifecycle you find yourself using, you must learn how to automate the process so that From the start to the finish, it is a repetitive task. You automate it, right? You automate it straight. So this is the difference between the waterfall model and the agile model, which is now with DevOps as an IC, right, on it, right? So the agile model, once you include DevOps, a culture of automation, right? Automating anything you want to do, make sure it's automated. You're practicing DevOps. So DevOps is not something that you can go and read in school. DevOps can be applied in any industry, in any process, even in the automotive industry where they build cars and all that. You notice that DevOps has been included there. There's a lot of automation in building cars, robots, carrying cars. Before, it used to be manual, but now a lot of automation goes into it. Production of goods and goods, especially in large factories, most of them have become automated. So in the software development field in tech, automation has also come in. And that automation culture is called DevOps, development and operation. Automating the workflow between the development team and the operations team is what we call DevOps. You will find this same culture in cloud computing. That's why you'll notice that it's very hard to split the two, right? The more you know about DevOps, the better you are as a cloud engineer. Okay? So, just 1 minute. I told you the agile model, right, is broken into micro stages, right? So, you know, what it means, why it's different from the waterfall model is that you can start building a product in the waterfall model, but you must finish it completely before anybody will see the product to test. But in the agile method, if you build up to, maybe you write your code up to 10 lines of code, you can test it. You test, check it, you bring it back, you continue again. You test it, you bring it back, you continue. So you are constantly iterating, you are constantly moving back and forth, back and forth. While the waterfall model, the code must be completely built before you move to the next stage. So you can see the difference there, okay? So the only drawback of the agile model is that it is not automated. So and that has brought issues between the dev team and the operations team. So with DevOps, that conflict is removed. Okay, so I wanted to just create this background introduction so that when we start looking at other areas of cloud and DevOps, you will understand what people are actually doing. It's not just you get a job and then you're just sitting down there. God bless you if they give you that kind of job. I mean, you get paid for sitting down, no problem. But you need to know how to automate. So we're going to learn Python, right? You are going to learn some not coding, right? Scripting, Python scripting, and a little bit of Bash scripting, right? We're going to learn that because you need that to automate. And you need it not just in DevOps, but you need it in cloud, okay? Because you can get a job and then you're managing like 100, 200 servers. Those servers are in the cloud. In the morning by 6, let's say by 8 a.m., the dev team all over the world, scattered all over the world, they all need to log in, maybe 100 of them, they all need to log in and start building the code from where they stopped yesterday. And by 6 o'clock in the evening, depending on the wherever they are, the one that logs in maybe from in Asia, you need to shut those servers down because they're not using them again. They are going to lose count. You end up just, accruing a lot of cost for the company because as a cloud engineer, you don't know how do I stop this server? Which server is being used by? the team in Asia or the team in the US who have not woken up. You need to be able to identify the servers they are using and ensure they are stopped when they are supposed to, they have closed for the day, right? And only the servers are running only when those people have resumed. You need to automate, right? And that's why you see that whether you're doing cloud or DevOps, it's very important for you to learn automation. And you can automate with scripting, Python scripting or Bash scripting. So you just set your code, simple lines of scripts that you write. The moment we use like Lambda to do that, you set it up, and the moment the thing sees that these servers are on, it will shut all of them down. Once it's 6 p.m., all servers are going to be shut down. By, let's say, 7 a.m. in the morning, it checks again, they are all shut down, it turns them on, and your life is easy, okay? So that's the culture that I'm trying to pass on to you. That's what you need to work towards. In every step of this iteration, of this software development life cycle, you need automation so that the people building the code, their life is easy. You help them save cost, you help the client save cost, you help everybody to manage the product better, and the quality of that product is going to be very good. Okay? So I want to stop here. Let's ask questions. What I will do is to you can turn on your videos, you can turn on your mics if you want now, and let me hear from you guys. I've enabled your videos and your mics. I've disabled mine for now, and I'm ready to take your questions. Yeah, Auden, you can speak.
Yes. But so I just want to know, for this trading, what's the duration and what are our expectation regarding the certifications, the AWS certification?
Okay, so duration is going to be 3 months, and it's going to be 3 days: Mondays, Wednesdays, and Fridays. The other days you're going to be having like labs that you'll be asked to do, and the expectation is I'm not focused on certification, because they will test you no matter how much certification you have. When you know the job, your certification means nothing. But I encourage you to go for certification because it's a way of validating your skills. It gives you some form of fulfillment. But usually the employer, the recruiters, they don't really care. There may be 1 or 2 big companies for insurance purposes and all that. They would want to have certified workers. But if they test you and you are certified, but you are not really good in what you are doing, it doesn't really make any. It won't encourage you. A lot of people in Asia, they have people who sit for them to write AWS certifications, and then when you call them and interview, you won't get anything out of them. So focus more on automation. Focus more on knowing the philosophy behind a technology, right? Why is this technology built, right? Why? Did they just build it to just play, or is solving a particular problem? What is that problem that it is solving? Once you understand it, using that technology becomes easy. You understand? Just like Facebook. Facebook, it was built as a business application for connecting people. Okay, but a lot of people don't understand for connecting people. But it was first sold as just a social, media, application and all that. But today, you see that a lot of people make a lot of money from Facebook. Facebook posts billions of dollars that they make every year. If it was just for connecting people and just laughing, they won't be posting games. They had a strategy, and today they are reaping those gains, right? So if you understand that this is what Facebook is, then you can start learning how to use it for your advantage. So that's what I'm trying to aim at. Okay, so be free. What you will learn will help you a lot in writing your exams, and I'm sure you will pass. But don't put your hopes on certifications.
Thank you so much.
All right. Is there any other person? Okay, come on, Drew.
Yeah, thank you very much, sir. We appreciate your time. Quick two questions. I want to find out for somebody who would want to get into, let's say, cloud security, how is DevOps going to help the person? And I also want to find out which kind of platforms, cloud platforms that we are going to use. Is it GCP, AWS or Azure in this particular cohort? Thank you.
Okay, so I'll answer the second one first. We're going to be using AWS, right? I'm just starting this thing, okay? So I'm still looking for partners, right? That, for example, I'm interested in cloud and cybersecurity, but it is either I'm going to take a course on it and then teach, or I'm going to get somebody who knows it. But answering your first question, which is how does it impact on cloud security? So, if you look at the software development life cycle, there's what we call the testing phase, right? In all the models, you have the testing phase. And we're going to look at an application like SonarQube, for example, right? Its job is to ensure your code has no bugs, code smells, ensure that you are using the code the right way, ensure that there are no loopholes, no security vulnerabilities, no unwanted security loops. That's what it does. And that's what we call DevSecOps, right? When you focus a lot on the security aspect of the development lifecycle, you are actually practicing DevSecOps. You are making sure that when the product comes out, that's why you see that some products, some websites and all that, they come out, and after some years, the people will report that, oh, so many people's identity they've been hacked because of these security lapses. When they were the cloud architecture, where this website is stored and all that, may be very, very, very porous. Okay, so it will help you understand. Probably when we look at things like security groups, NACO at the subnet level, when we're talking about networking, when we look at, as I just told you, SonarQube, when we are iterating, that's when we'll be looking at CI/CD using like Jenkins, right? You will see it will report the code and tell you that this code is good. There is an acceptable level of bugs that you will set. Maybe if it has less than 10 bugs, accept the code as good. If we checks, the code, it comes out as they have like 100 bugs, it will tell you that this code is not good enough. You have to take it back to the development guys And guess what? Because we're running an automated system, they will get the report automatically, and they will just go back again and start doing their job. Okay, so you will get a lot from this if you stick around. You will get a lot. Okay, John.
Thank you, Mr. Informer. I'm sincerely grateful for this kind of initiative. I hope you can hear me, sir.
Yes, I can.
Yes, yes, yes. This is a good initiative that will be mostly celebrated because a lot of people are looking for this kind of opportunity for hands-on on this kind of practical aspect of it, which you have brought to our our place, our space, and you gave us the opportunity to come and learn. I sincerely thank you for this, and God will bless you. I saw the platform. I tried to download some of the applications which I've already installed on my laptop, but there is some errors that I saw when I installed the Ubuntu on my system, which I can also send to you so that you can help us correct why the error came up. Thank you so much, sir.
Okay, thank you, John. I want to make this cohort and every other one um, mm, as practical and solution seeking as possible. So I wouldn't really want to feed us because the job of a tech guy is to solve problems. So what I will do, but at the initial stage, of course, yes, I'll try to help, is, I would encourage you guys, whatever issues you have, take a screenshot or a short video, post it on the Telegram group, right? And then, put the challenge you're having, and then we'll see it, and then we'll tackle it. Nothing is too big for us to tackle. We'll tackle it, right? So that, because when you are involved in the solution, finding solution, you get better, right? But when you that's why you say I did the video. I didn't want us to meet for the first time, and then we will start by installing, and then everybody, so I don't have this. My computer is doing this, and it will just be chaos. So I wanted you to. There are a lot of kind of missing information from those videos, and I did that on purpose so that you can, research. This job is like 90% research, right? Reading and research. Okay, so yeah.
The platform where to communicate with you is not on the WhatsApp, on the Telegram. Maybe we need to create another where we can easily send message to you directly.
I have a Telegram channel.
Okay, maybe you just give us the Telegram channel.
Okay, let me just let's see, let's send it. I'll send it now. I'll just copy the whole text of what I used when I sent it out. You can ask your friends, people who are new, who are new in the, in tech. This is the time that they can join, because the moment we start moving to other, areas, it will be difficult for them. They'll start dragging us back. So let them come and join now. Let me get the link quickly. So, I mean, while I'm doing that, if you have any other questions, you can ask. I encourage us to be interactive. You know, in this kind of place, this is where you ask all. No question is dumb. No question is foolish. No question is bad. Just ask. Just ask. When you ask, right, we'll answer. Why is it showing? Okay, I know what to do here. Or is somebody wanting to contribute? You want to contribute? You want to, the next class we're going to be looking at the basics of computing. We need to look at that. Oh, somebody posted it, right? Good.
Yes, I posted it, but I guess the question that John was trying to ask is that Telegram group doesn't have the ability to contribute. It's basically the administratives that can contribute in every other person muted. So I think that's what he's trying to say, except you
Is that
make that
true?
possible. Yes.
Yes, yes. Where we can also contribute, put input.
I didn't know that. I will go back and wow. I'm just saying, I didn't know. I will go back and I'll make those changes. Don't worry. At least before in the next 1 hour, I'll go back and make those changes. I really didn't know that.
Not a problem.
Okay, so yeah. So I was talking about computers. I was talking about looking at the infrastructure itself, because it ties into what these cloud service providers are doing. They have massive infrastructure built, in places, but the truth is that it's just a replica of your small computer. So once you understand some areas of the computer, right, and we look at hardware, we look at the software, we look at various types of software, we look at cloud computing itself, right, and all those stuff, services offered, and then at least let's move systematically. So by the time we start going into using applications, you are already grounded, you already understand, when I tell you something is hybrid based or cloud based or on-prem based, you understand what I mean. Okay, when I say let's increase the compute resource of a particular server, you know what I mean. When I say, so and then you'll also be able to see different types of boot processing processes, the way computers boot, and all that stuff. Yeah, so we'll continue with that one, and then from there we'll now go to, once we are done with all that, we're now going to learning a particular software, which will be Linux, and we'll really go into that to understand how the software works, right? The operating system. So we'll move systematically, and then we get into cloud, where we start looking at, practicing what we've learned in the basics of computer. We'll start implementing them in the cloud. So you will not, I don't just want to bring you to click here, click ops, like what we call click ops. Click this one, then click that one, then just do this and do that. And tomorrow you are in an interview, they tell you, you know, tell me about this storage. You cannot say anything. And though you are certified or you have certificates, but you cannot say anything, right? So I just want to pour myself what I know and give it out. So,
so the question and I raised my hand. Maybe I should just raise it back down.
Yeah, go ahead.
You mentioned agile and the waterfall method of SDLC, and also you talked about spiral and something else. What is the other two? What's the difference between the spiral and the agile methodology?
Okay. Basically, the spiral method is more I would say they are built for different kinds of sectors, right? Built for different. Let me just pull out this. I know I have the spiral here, but I didn't want to talk. There's even what we call the RAD, but all that to me doesn't really, you're hardly going to encounter those things. That's why I didn't just want to go there and just, So here is the this spiral method. I'll share my, let's see if I can blow this up. Just 1 minute. Okay, so I'll just share my notes here. So this is like the spiral method. Okay, so if you notice that it's divided into 4 parts: 1, 2, 3, and 4. Right, and the spiral method, the way it works, you don't need to know everything. You just be walking. Whenever some information comes, and you add it, and then you continue walking. So I think that's one of the disadvantages, right? So basically, this is what it is. You start from a point, right? From a point, it has some risk management and all those stuff, including then you probably make a prototype, and then you design, you code, you integrate, you test, you implement, and then you release the product. Then you start again another next phase of planning, right? Again, and then you move to the next phase. You move to the next phase. So it is a complicated model. It's not as straightforward as you have the agile or the waterfall, right? So these ones are just various models that are out there that people really use, right? So I just put it here because I wanted to just show that there are many software development life cycles and models that are available. But what you will encounter most, there is the iterative model, right? This is iterative, where there are multiple building, testing, everything at once, stage 1, second build, third build, and all that are happening, so, and all that. So there are many models, but I just wanted to pick out 2. So don't worry about that spiral model. You may never encounter it. I'm not sure anybody will ask you. There is a V model, you understand? So nobody will ask you. This is the, which one? This is RAD, you know, the RAD model, right? So yeah, it's a long write-up. So I didn't really want to start going and to bore you guys. What you just need to know, the basic, the most common is what I told you. The waterfall, which is known as the traditional one. That's what everybody, you know, will do. You know, and you can see that from when you are building a house, for example. You cannot start the house from the decking or the roof. If the foundation is not complete, you cannot move to the next stage, right? That's the waterfall model. That's why when there is no money, you just abandon it till when there is money, you continue from where you stop. Yeah. So, but look at it that way. That's the waterfall model. And then look at the agile model, like the way some of these construction companies build. They, they probably want to build a bridge. They split the various parts of the bridge, the pillars, the whatever, into various departments, and they all go and they cast those areas, and then they just one day come and bring everything and they just assemble, screw and bolt everything up together. And the next day, people are driving and they see a bridge, right? So, so that's another model. That's like the agile model. Okay, so but the other models you don't really, you will never hear them, you know. So yeah.
Thank you.
Okay, so I don't like why we are about 20 people here. Is anybody in tech? Is anybody working in tech? Is anybody you know, a DevOps engineer? Is anybody a cloud engineer? You know, let me know. I like us to, I mean, you know, I like us to know, to let's get to know you. Nobody's going to ask you any question that oh, tell me this and maybe you can't answer. Don't be afraid. I don't know everything, you know. I don't know everything. Nobody knows everything. So I like to hear some people talk. I like to, you know, get some comments from people, you know, contributions, you know. I want us to build this channel, let it grow. Let's, you know, call your friends, tell people you know who've been wanting to learn. This is, you know, it's going to take a lot of energy to do this, but I want to do it. That's why I'm doing it. So call the guys that you know, let them join, let them, you know, whatever videos are out there, let them go ahead and, you know, subscribe, like, do that one just to help me while I'm showing you something free. Okay, so
Um, I just want to ask for something. Do you kind of have like some videos just to help to read ahead or something like that? You know, maybe just to get ourselves familiarized with this whole DevOps thing. So while you teaching along in the class, we can easily relate alongside as well, and also prepare our question too.
okay. For now, I don't have videos that I've done. Probably very small videos in my YouTube channel that I did some while ago on simple tasks, how to do this, how to do that on AWS. Yeah, well, but when it comes to the next session, I might just, what I can do is maybe I might take later today to, you know, just go and surf on the web and see if I can get one or two things, and I'll put it in the comment in the Telegram channel. So whoever is interested can just, you know, can learn, can learn something from it. Yeah, I'll do that.
Thank you.
All right. So I think there might not be any more comments coming in. So, except someone cuts me off. For today, this is just like an introduction. We'll meet on Wednesday again, and we're going to look at the computer itself and just try and familiarize ourselves with those basic things that people just ignore and assume, "Hey, we all know." So we're just going to familiarize ourselves with that, and then from there we move on to studying one operating system, which will be Linux, and from there we go to AWS and start looking at various services. Then we come back to looking at automation. We'll probably take some while looking at Python, trying to build, scripts, and then, we go back to other third-party tools, right? And we should be good after 3 months. As long as you put in the work, as long as you study, you don't just take only what I tell you, you research, you read, you will be good. So, if there are no more questions, I would like to say goodbye. Thank you for attending. I'll see you on Wednesday. And, as much as possible, tell somebody about this. Watch the videos. You can still go to the YouTube channel and just watch, subscribe, make comments. I mean, if that doesn't cost anything from your end, right? So and let's grow this thing, okay? So I'll say bye for now, and we're going to see you on Wednesday. All right. Okay. So welcome back to this session. Today, as you can see, we are going to be looking at the Linux operating system. We're going to be, checking, starting from the philosophy of this operating system, and then we're going to work our way through learning basic commands and, getting some labs that we're going to do. So this particular topic, the Linux operating system, we are going to be looking at it for the next 2 weeks. And then we'll move on to the next application. But for the next 2 weeks, probably the next 6 days, we're going to be looking at Linux to make sure we really understand, about what about it and all that. So without any further talk, yeah, let's go. So I just made up this simple, I just blow it a little bit. I made up this simple drawing to make you understand, what Linux is all about. But before we go into this, I want to give you a brief history of Linux, how Linux came to be. So in telling you that, I have to talk about basically 2 people. One of them is Richard. Richard is a Richard Stallwell, right? He was one of the people who started, developing. Just 1 minute, I'll just check quickly. I'll come back to you. So I want to make sure I get his name very, very clearly.
What's next? In IT, that's a question that must be answered on a regular basis. At Verinext, we're a Hewlett-Packard Enterprise Platinum Solution provider that can introduce you to transformative business technology solutions that will help you prepare for everything that comes next. That includes solutions like HPE GreenLake, an edge-to-cloud platform that is flexible, scalable, and allows you to secure data, deploy resources, forecast capacity, and only pay for what you use. If you need more capacity, HPE GreenLake allows you to make it happen with a simple click of the mouse. Put simply, Verinext makes technology truly work for you. We're passionate about helping you simplify and modernize your technology environment so you can achieve your digital transformation goals for faster time to value. Let us help you activate the innovation you're striving for and make sure you're ready for what's next.
Celebrate and save on top-rated mattresses during Raymore and Flanagan's Anniversary Mattress Sale. Or finance your mattress for as little as $15 a month with no interest for 72 months. Grab these deals while they last, only during Raymore and Flanagan's Anniversary Mattress Sale.
And the other one of them, of course, is Linus Torvalds. Okay, and that is the one most people know. One most people know is Linus Torvalds. Okay, so let's just call him Richard because that's his first name, right? That's his first name. And, Richard was the first guy who actually started developing, stuff that had to do with Linux. So at the beginning, it was called, the first application that was created was called Unix, right? And, when Unix was created, it was very expensive. People were, you had to really pay for you to use it. That was probably in the 70s. So in the early 80s, Richard started the GNU project, GNU project, right? Let me look for to type here. Okay, so he started what we call the GNU project. And what that means was GNU is not Unix. That's what it means. And Mr. Richard was a software activist, right? He was a software activist. So all he did, most of his life, he spent it trying to push the narrative that, look, software must be available to people. People must be able to use software, and they must be able to use software freely. They must be able to, software must be something that they must be able to have the freedom to use, the freedom to distribute, and the freedom to modify that software. So that was the time when many companies were developing and using their own Unix-based softwares. So today we have many like Linux distributions, right? And most of them find their root, right? They were developed from these GNU tools, right? From what Mr. Richard himself, what he was able to do to achieve. So, and fast forward to 1990, in the 90s, we now have had somebody else who now, he was a Swiss, I think he was a Swiss American student. He was in Europe, in the university, and he was trying to develop stuff to his project using Unix, but he just found it very. I think at that point they withdrew the service, the free student version that was free, and he couldn't pay for the paid version. So he decided to build his own operating system based on Unix. He is Mr. Linus Torvalds, and he eventually built it based on the already existing GNU commands and structure, and he was able to build Linux, which means Linux is not Unix. That's what it means. That's what this means. So he was able to build Linux, right? And Linux has become the most popular command line interface operating system. Okay? I just use the term CLI is the same thing as command line interface, right? Which is you see a terminal and you don't see any graphics, you just type. While the GUI is called the graphic user interface. So an example of the GUI interface is Windows, the Mac. An example of a command line interface operating system is Linux, right? And Unix. Well, Unix is a paid operating system. It's very expensive. Linux is free because that's what Linus Torvalds wanted to do. He wanted to make sure people can use an operating system that is like Unix, built like Unix, but free. Going back, just like Mr. Richard, right, who was a software activist and wanted to make sure people were able to use software freely, distribute it freely, and modify freely. So this is why Linux today is the most widely supported operating system, because it has so many, the support base is very wide. So if, for example, let's see how I can, let me go, I'll share my screen now.
Refresh the everyday with Mentos gum. Yes to fresh.
Okay, so I'll share this tab. So if we go to Ubuntu, you will see in Ubuntu, you see that there are many. Yeah, so you will see that we have, for example, this is Ubuntu website. We have the server, the desktop version, we have the server, we have the core, we have the cloud. All these are for various situations, right? The ones you use for like the core, the ones you use for like IoT stuff, like small PCI cards and all that. So you will notice we have the long-term support, right? Now, if you look here, you'll see the latest LTS version of Ubuntu, right? LTS stands for long-term support, which means 5 years of free security and maintenance updates extended to 10 years if you are using Ubuntu Pro. You see that? So this Ubuntu, this is Ubuntu. It's from the Debian distribution of Linux. And Linux, I'm just trying to show you that Linux has is the most widely supported operating system, right? It has a lot of contributors because it's free to distribute, it's free to use, and it is free to modify. So because of that, it has given rise to numerous flavors, distributions of Linux, right? So I'll just go quickly to give you the distributions of Linux that we have. Just a minute, try and share my screen again. So if you can see the screen, I see someone says, John, you say nothing is showing. If you can see my screen now, can you comment yes, so I will know. Okay, Andy says yes. So if you can't see my screen, it means you probably log out and log in again, and you will be able to see. Before we continue, I'm actually streaming this live on YouTube, my YouTube channel. So the moment we are done, you can go back there and it will be immediately available. You can go back there and watch. Okay. So I was talking about. Let's move this. I was talking about Linux distributions. So think of it like Windows, just the way you have a Windows 95, then Windows 98, Windows 2000, Windows Me, which is Millennium, right? Just like that, up to Windows, 10, Windows 11. So they're all Windows, but Windows 95 is very different from Windows 2000. The GUI, the way where things are located is very different. Same thing with Windows 2000. It's very different from Windows 10, right? Very different from Windows 11, where things are positioned and all that, where you start, where you stop, and all those stuff. So think of Linux distributions as various. It's not exactly this, but I'm just trying to use it to explain for you to have an idea of what I'm trying to say. So it's like various types of Linux operating system. Okay, so there are various types. So and so we have the first one I want to show you, introduce to you.
With Asana, AI teammates can help level up your goals by connecting them to relevant projects. So every team knows their role in the bigger picture. Asana, the #1 AI work management platform. Try for free today at asana.com.
Is the Debian. Just 1 minute. Okay. So, right, Linux distributions, which are like, we call them distros, right? They are different flavors. Let's just use that word, right? Of the Linux operating system, right? So the first one is Debian, right? Which is like an versatile distribution. So they have a lot of free software principles and it has a very large community. Ubuntu is a Debian distribution. That's why we can install it for free, because their goal, they are committed to, developing free software that is available to be used, to be distributed, and to be modified. So if you want to join their community, you can actually join their community. Okay, so they have that this principle of developing free software. We have another one, which is a Fedora, right? Developed, which is also sponsored by Red Hat. Red Hat is a company that makes, softwares and all that. So, yeah, that's Fedora. It's by Red Hat, right? And it also has a lot of updates. But, the reason why I'm going with Debian is because it is the most widely used. But I just want to make sure you don't, you're not, I don't want you to be ignorant of other distributions that are out there. So we have another one, the Saint OS, right? So it's also a it's also like, it's like Red Hat itself, but it's a free version of Red Hat, okay? And it is very stable, right? It's known for its stability, right? Let's type that. And then and use in servers. One type of CentOS is the Amazon Linux. Amazon Linux is the CentOS flavor, while Ubuntu is a Debian flavor. Okay, so, and then we have Red Hat itself, which is a very stable distro, but it's not free. So that's why you see that Fedora is like a free version of Red Hat. You see, but then it's not like Red Hat. Red Hat is is for enterprise, you know, for enterprise solutions. So, and then we have another one. I just wanted for you to know that, which is the Kali Linux. You know, this is for if you are into cybersecurity, you know, design for penetration testing, right? Security auditing, things like that. So it's mostly, you will see it pre-installed with the tools that you probably use in carrying out your cybersecurity, work. It's at the background. It is the operating system that it hosts the tools that you use for your security work. So Kali Linux is a specialized distribution. So I think we'll end there. We still have others like for maybe gaming. There is one like they'll call the Stream OS, right? And other lightweight ones like Ubuntu, right? That's a lightweight, one. We also have the one that has a lot of privacy features, like it's called Tails, So it all depends on what the situation is. As a cloud engineer, as a DevOps engineer, it is important that you understand these distributions, not for you to be able to use them. I mean, you really may not be able to learn every one of them, but the good thing about them is that the commands are very few. I think it's Ubuntu basically that has the most different command line. Most of them share the same kinds of commands. So yeah, so these are called, they are like types of the same thing, right? And the reason they are called flavors because this one might contain more salt than this might have more pepper than this might have more onion than that, and all that. But eventually, it's like I've taken different, taking pepper soup cooked by different people. Mr. A zone might have more salt, Mr. B zone might be more peppery or spicy. Mr. C zone might have more onion, Mr. D zone might have more, whatever, more meat, right, or more protein. So, but at the end, but all in all, they've all prepared pepper soup for you. So that's the way this is. Okay, so each of them typically use the Linux kernel, right? And I will go up and try and explain what the Linux operating system, how it looks like, how you interface, right? So now, this is what we call, let's look at the most innermost circle, right? Which is called the hardware. Okay, the hardware. Now, this hardware, as we talked about the computer the last time, and we tried to look at, the computer in whole, the software, the hardware, the infrastructure. And, excuse me, and This computer, your hardware, cannot operate on its own. It has a lot. This hardware now is your everything that is physical, called the bare metal, right? It cannot work on its own. It cannot do anything on its own, but it has power to do. It can do, but it needs to be, it's like a slave, right? That needs to be told what to do. So that represents the most, the innermost setting, right? That's the hardware. And then we have the system calls and the device drivers, right? We talked about that when we're looking at the second class, when we're talking about operating system. Okay, you can go back to it just to understand. Device drivers help you include more hardware to the knowledge of your computer as a whole. It helps to introduce more hardware. So if I add a printer in the original computer, it's just your processor, your memory, your storage, things like that. So if you need to add your networking, right, you may need a device driver will introduce it to the other hardware, right? The CPU and the memory, they will realize, oh, okay, there is this guy called the network card, right? So that's what device drivers do. They introduce other hardware, bare metal, to the computer, add them to the fold, right? System calls are the actual low-level information that interacts directly with the hardware. Okay, the combination of your device drivers and system calls is what we call the kernel. Okay, so when you hear the Linux kernel, you hear the kernel, the operating system kernel, it's a combination of these two. Okay, and then on top of that kernel, you have your shell, which is that blank surface. When you open your Ubuntu terminal, what you see the cursor blinking on the blank surface. That is the shell. That is, it is from that, is on that shell that you as a user can now interact with the kernel. So you use the shell, you type commands on the shell, and the shell passes those commands to the kernel. The kernel converts them into low-level language. We talked about this last class, of how the user uses the operating system to control the hardware to achieve results. So we are looking at, and it's the same, every operating system, this works, it's the same principle, okay? So, but now we are looking at is, we are going deeper to we're systematically getting into where we are supposed to be. So if I just brought you here to start explaining this, you may not really understand for those who are starting from scratch. So the user represents the outermost circle, right? So this is the architecture. This is the way it is, right? I log into my Linux, I see the shell, which is the black surface. I type my commands. Those commands they are hidden inside your kernel. They are all stored in your kernel. So you have to know those commands. So when you type any command, the shell sends it into the kernel to confirm if this command is there. If it is there, whatever you have instructed with that command, it will pass to the kernel. The kernel will take it, convert it to low-level languages, binary language, zeros and ones, and pass it to the hardware. And the hardware understands that language. The hardware will execute the command, and you will see it, and everything will come back again to the kernel. The kernel will translate will send that same information to the shell, right? And you will see the output on the shell. If it's a printer, you will see it. Okay, so this is the that's why I said all Linux distributions use the Linux kernel. I didn't want you to be unsure of what the kernel means. That's why I brought you here to try and explain all that. Okay, so having done all this, what I want to do now is to go on my virtual box, and I'll ask you guys to get into your virtual box and launch your Ubuntu software operating system. So here is my Ubuntu operating system, right? And when you select this, the one that you've installed, you come to start, and you click start. And when you click start, it will load. Okay, so now that's my Ubuntu. It's running now. Okay, so now what you're seeing now is the GUI version of Ubuntu, right? So you now know what GUI means, graphical user interface. We can see it's like Windows, it's like, all those other applications, right? We can click on file, you can do ClickUps, okay? You can check stuff and all that, right? So this is basically the GUI version, but in the Ubuntu server doesn't have this. You just see the plain screen, the black screen. You just see that. That's all you see. Okay. So if we come to settings, for example, we could go to the background, and you see various backgrounds, right? You can change the background from the original one that is there. You can decide to change it if you want, So just to show you, it's just the graphical user interface. So if we want to get to the terminal, there are a number of ways, right? Haven't logged in. There are a number of ways we can use to get to the terminal. The first is we can just right click and open in terminal, and you will get to the desktop directly. The other one is we can come here, select that, and we'll see our terminal here, and click it. Or we just come to the search box and type terminal. So we can select our terminal. Okay, so whichever one works for you, you can do that. So I want us to get into our terminal. So I come here, I click this applications list, and then I type terminal here, so it filters terminal for me, right? And then I select terminal, and voila. This is now the terminal with my blinking cursor. This is what we call the shell, right? So it is on this shell that I interact with the hardware through the kernel. The kernel is hidden behind this shell, okay? And so we are now going to take a more technical look at where we are now. So there are the philosophy of Linux is this. I'll type it here so you see. It's the use of small commands let me use this one. It's the practice of combining small commands to achieve big results or complex solutions, right? So that's basically what you can use. That's the philosophy behind it, okay? So I can, for example, I can just type a command now and it will just show me stuff. I can just erase my shell screen, right? I can, you know, do something, type another command, and I've created a file. When I check, I see that the file is here. I can also remove the file, you know. And when I check again, the file is no longer there. I can clear my screen. You see, I'm using small commands, just one or two commands, and I'm just achieving all these things. In Windows, you have to click, you have to right click, you have to double click, you have to, you know, dig into search and all those things. I can just with one command check for my name. Oh, I'm workstation, right? I can, you know, check for a particular command, you know, and I can just see the location of that command. Okay, but we'll take it slow. So that will now bring me to exploring basic Linux commands. Okay, so the first one that I'm going to show you is the ls command, right? The ls command, it simply means list directory. And what that means is you want to check the contents of a directory. Directory is the same thing as a folder in Windows. Just the way you have lots of files, lots of subfolders inside a folder, and you're looking for something and you just double click that folder and you see all those files, you know, in the folder, right? That's what ls does. So if I say ls, right, it just pulls out all the directories that are inside my operating system at the moment. Okay, I will stop here and try and also explain more for you so that you can understand certain areas of let me just check and okay, so you can get some small understanding on the way the file system, the way the file is structured. Okay, so let me share my screen again and let's get there.
In 3, 2, 1.
I'm just a stunt guy.
Not today, you're not.
I had to do something. It's important. Something's bound to go down. This here is gonna be a night that we never gonna forget.
Groove it, baby.
Okay, so I want us to look at the file system hierarchy. Okay, so at the helm of every Linux operating system is what we call the root directory. It is the father of them all. If you can get to the root directory, you have all the powers. You can do and undo. It's almost like sitting on the table with the hardware, right? You can command the hardware to do anything, right? And under the root directory, we have many other directories. We have the bin, the sbin, the home, like that. We have the. Now, if you look at the bin, you see that it's the user level command, right? And it is stored in the bin directory, right? So when the user sends a command, like I was doing on the shell checks the bin folder, which is this bin directory. If it's available, what I explained to you that time, it sends a command to the kernel who executes the command. So every command you as a user will be using in your Linux operating system will be stored in your bin directory. And then we have the admin level command, which is stored in the sbin directory, sbin system. Okay, so usually if you are in the root level, you probably will have access to admin level commands. Like, you know, when you want to install stuff on Windows, as you click install, it will say, do you have admin privileges? Will you, administrator privileges, right? And you have to click yes or no, or sometimes it will say, ask your administrator to approve of this installation, right? And then before you, so think of it as something like that, a higher level of privilege, right? So those commands are stored in the sbin directory. We have the home directory, which has where you as a user, right? You just like when you're logging in, you have maybe a Windows computer, you have 3 or 4 people using it, and everybody will create their own user credentials. So once you log in to your user, you discover that all your files, your desktop is different. The way your desktop will be is different from the way Mr. B, when he logs in using that very same computer with his own user credentials, his desktop is different. So for every user, you have a home directory. Okay, so if I'll show you something about that anyway. And then we have the temporary logs and files, the 10. TMP. Okay, we have the USR, right? User level packages, right? So these are default directory where this is a directory or folder. You know, all of them are directories or folders. Another word for folder. Okay, but in Linux, mostly we call them directories. So it's a default directory for third-party packages, right? So for example, you download Google Chrome inside your Linux, you download it. So all the files that Google Chrome will need to operate will be stored in this /user directory. You have the /opt, right? The optional directory for installing other applications that are not available by default. Same thing, you know, similar to the USR, sorry. Okay, and then you have the media. If you want to hook up something like your hard drive, an external hard drive, you know, now you have also the MNT, you know, which is they are all the same thing, right? So this is where most of those things will be, that external hardware will be set up. You have your root, which is your super user, as I told you, right? You have your var, variable data, that's what it means, right? It changes frequent, things that frequently they change, like logs. And then you have your etc. Think of it like etc, right? It's a default location for all system configuration related information. Okay, so yeah, so I just wanted to you know, show you that so you can understand something about the Linux the Linux operating system, the file hierarchy. Okay, so I'm really not able to log in. I don't know why. I just forgot my password. I've always been trying to. So I'll come in again. I'll stop it, power off, and I'll power it on again. For some reason, I don't know why I can't. So I'm setting it up. I'm starting it again. So I probably will go back and check. Okay, so for example, this is the user interface. This is my this is my home screen. Okay, if someone else has this is using the same Ubuntu operating system and you log in with your own, your home screen will be different depending on the way you customize it. Okay, so I can just right click here and open terminal. Okay, and I am back in my work in my shell. Okay, so let's kind of understand the way the command line is structured. Okay, I will just open it a little bit. So now, if I say echo hello, right? And immediately we just see hello there, right? If I say car, okay, it says car is not there, so I don't know this password. How am I going to see? Okay, so I can't install anything. Okay, anyway, fine. Okay, so like I said, if I say ls, you see something. If I say echo, this is an intro to Linux. You see that it repeats it. Okay, so what it means is that, like I just told you, when you put something, you enter a command, immediately there is an output, right? There is an output. There is when you enter a command, it gives you the opportunity, to have an output. So all commands are like little computer programs that are stored somewhere in your operating system, right? The echo that I used just now, echo means repeat whatever is in front of it, right? Print it on the screen, let's see it. LS means list all the directories in a particular place, right? They are all little computer programs, right, that are stored somewhere in your operating system. And when I told you about the file hierarchy structure, you can immediately relate to know that they mostly are all stored in the bin, the /bin directory, right? So now your commands, the structure of a command, it usually starts with a command name, then you have options, and then you have inputs. Okay, so sorry about that. I don't want to clear the screen. So you have your command name, and then you can have options and inputs. But so far, the ones I've just showed you, it's just a command name. ls, that's the command name, that's it. It's enough. Echo, right? It's a command name. Then it doesn't have options, it has inputs, right? Echo this is an input, right? And it will echo that, right? So this is how the command line is structured, okay? Right? So what the shell will do is to search the command line in your bin/bin folder and check what if it is there, and if it is there, it will carry out the input that you have asked it to do. If it is not there, it will give you an error. For example, echoes. Echoes is not there. So if I say echoes, please, which is an output and input, or it will output for me, it will search, you see, and it will say, this command echoes is not found. It will now say, did you suggest for you, did you mean this command echo, from whatever, right? So you see, it went to the kernel to check in the SB location. When there, it didn't find the one that has an S. So it gave you an error. It didn't see it. So it didn't carry out the command. Okay? So know where a command is located, right? You can just type, let's clear the screen. Clear means clear the screen, C-L-E-A-R. And when you type, don't give any space. Clear, and then hit enter. To know where a command is, the path where a command is located, you can use the same command, echo, and then dollar, then path in caps. So you see, when you hit enter, you will discover that this echo command, you remember the hierarchy, the file system hierarchy, right? This same echo command, we are looking at where is it located. It's under /use sr /local /sbin. You have it there. You also have it in /usr /local/bin. You also have it in /usr /sbin. You have it in /usr /bin. You have it in see, these ones have local first before them, and then you just have the normal one. We have it in /sbin. You have it in /bin. You have it in, you see, just like that. But the way the operating system works is that once you type the command, it will search, right? It starts to search from the left of the screen. So it will come here first and search this part, this location. If it doesn't see the command, it will move here. If it doesn't see it, it will move here until it sees the command. If it can't find it, then it will give you that error output. It also mostly what you are seeing now, the echo is usually mostly being used from this location right now, because once it finds it here, it will ignore the rest locations. Okay. If you notice, there is always a /, right? But if you're using stuff like your C PowerShell, it's usually a \. But in Linux, mostly it's /. Okay, so now, if you want to find commands, there are many. You cannot memorize all the commands. So there is what we call the Linux manual, right? Which is broken down into 8 sections. We have the user commands, the system calls, the C library functions. We have devices and special files. We have file formats and conventions, games, miscellaneous, system administration, and all that. But you pay attention basically to sections 1, 5, and 8. So to access the manual, all you just need to do is to type man, right? Okay, let's say man. Okay, let's say man. Let's put a command there, man. Man, okay, which, let's just use that. Okay, now I'm just trying to give you let's try man. Now, the reason I'm saying that is because when I typed to man, it was telling me what manual page do you want. For example, try man. So what it means is that go to the manual and check for manual itself. So it will describe what this manual is about. So if you type your man, this is manual, that's what it means, the short form. And then you type a command. So it will take you to that command and explain, right, what the command does. Okay, so what I did here was man space -k space which. Okay, so I was targeting this which command. Okay, now this, forget the which, forget the -k. I just want to show you that Linux has a manual. Okay, now and I told you there are 8 sections. If you notice, you will see in bracket 1, you see 8, you see 1, you see 8, 5, 6, right? Pay attention to anything section 1, section 5, and section 8. Those are mostly the commands that you mostly use as a DevOps and cloud engineer will be located in those sections. Okay, but then, right, it tells you what the command is actually used for. So, and then it will go down and let's say man ls, just so that we can see better. Okay, so the ls command that I've been using, it tells you the name, ls, list directory contents, okay, and then it will now give you how to use it. You put the ls, you now use an option. You see what I said? So it accepts an option, right? And you can actually, and then you can actually, it accepts a file name. Okay, so if, for example, I say ls, and I may not put an option here because this option is optional. Okay, and when you see 3 dots here, it means you can have multiple options. So the same thing, if you see 3 dots here, it means you can have multiple file names. So this is just the synopsis, the way you can use it. Okay, and then the description, it will now describe, whatever you can use it to do. Okay, and then arguments, which are the options, right? It will show you various arguments. If I use a -a, what it means is do not ignore entries starting with a dot. Anything that starts with a dot is a hidden file, okay, in Linux. So if you don't want to hide hidden files, you want all files to be shown, then if I say ls, then I'll put a space and then I'll use -a. Full. Instead of using -a, I will say -all. Okay. If you are using the capital A, this is what it means, right? Scroll down, you see various options that you can use with your ls command. It goes down and down, right? All these are various options that you can use with your ls command. Okay? And you end up at the end of your page. You can press the letter Q to quit, to come back to your terminal. Okay? So if I clear the screen and I want to check for all directories and the ones that are even hidden, I know now that I will do ls space -a. And you see, it will pull out both the ones that are hidden, that are carrying dots. But if I just say ls, it won't show me much. It will just show me the ones that are not hidden. You see? So this is how to use the man pages to understand how to use commands. Okay, so I wanted to show that to you so that you will at least you will understand you will get an idea of the of you will understand that you don't need to memorize commands. You don't need to, you have your man pages that you can use. For example, CD is the same thing as change directory. So it helps you move from one folder to another, right? So if I do ls and I see that there is desktop, there is downloads, there is documents. If I want to move to any of these folders, I will just say cd space. If it's desktop, I'll type desktop, and it will take me to the desktop folder. Now I'm in the home folder, so that's why nothing is showing here. Once I move, this address line will the desktop will be added to it. So that's how you know where you are. One of the ways you know where you are. You see now? Now I have desktop added to it. Even if I don't know that this is where I am, right? You can also type another command to know your location, which is print working directory. That is where you are currently located. So if I do PWD, it will tell me where I am. If I hit enter, it will give me the absolute path. So I am in my home, in my workstation directory, and in my desktop. That is where I am right now. I am in the desktop location. So this is another command for knowing where you are. CD is a command for moving from one location to the other, one folder to the other, right? I will tell you about, let me tell you something again. Just a minute. Okay, so just a minute. I want to tell you something before we move forward. Just searching for it in my notes. Okay, so let's try and understand what, if you look at this whole line, you'll notice that it starts with a name, right? The name that you gave the this operating system at you have also, when you were installing Ubuntu, you were able to give it a name, so it will carry this name, right? Then you also give the operating system a name. You give the username, and then you give the operating system a name, right? And then once you are done with that, when you get into your terminal, you will just see basically the operating system name and then your name. Okay, whatever name you gave the account, right? And then you will see a small sign, a tilde sign there, and then you see a dollar sign. When you are in this environment, you are in your user environment. Okay, and in this user environment, you as a user, you can, if you want to move from any place along inside this your user environment, there are certain notations you need to know. For example, a dot. For example, dot dot, right? For example, the forward slash, what do they mean? So okay, what do they mean? So now, if I want to move, I just introduced the one command to use, the cd, which is change directory. Okay, let's ls first, right? ls, and then we see that we can move to desktop, or let's go to documents. Let's cd to documents. You must type the exact way it's written. It will not accept small d, right? It's not the same. Okay, so we hit enter and we are in documents. If I ls to check what is inside documents folder, nothing. Okay, so now if I want to if you notice there's a forward slash there, right? Which means in my home, documents is inside my user environment. That's why you're seeing that forward slash. Okay, and if I do my present, I told you another one to know where I am currently, print working directory, it will show me the relationship, right? It will show me that in my home environment, right, I am in a workstation folder. Yours will be different, and then I am now in the documents folder. So now this is my present location. When it shows you this is called the absolute path. Okay, so there is an absolute path and there is a relative path. Okay, the absolute path shows you from the beginning where you are, the parent, the child, the grandchild, right? If I want to just reference if you want to reference the relative path, you will use your tilde, right? And let me not go there, that will confuse you. So I have introduced 3 commands to you: the ls, more than 3, the cd, the print working directory, the echo. Echo is just to print something on the screen, okay? And the man pages, which is you type man and space and type the command you want to check. If I want to check pwd, right, let's go there, man space pwd. It will show me that the name of the command pwd is print name of the current working directory, and you can use it this way, pwd with an option. So it means you can have multiple options when you see 3 dots, right? And then it describes the options that you can add. If you put a dash capital L, It means use the print working directory from environment, even if it contains symlinks. Avoid all symlinks. You put capital P, right? Help. If you say pwd-help, it will display the help and how to use it. Okay, it will take you to this man pages. So that's another way of getting there, right? And it's not a long one. So basically, these are the options you can use with it. So you press Q to quit and come back. So I've shown you those commands, okay? So if I want to move from, remember, this document is a sibling to desktop. If I want to move to desktop right now, I'm inside documents. I cannot just say CD to desktop. If I do this, what it means is that inside documents, there is a desktop folder. But we know that's not true. There's nothing there. And you can tell by running a list directory command and hitting enter. Nothing. Okay. So if I want to move to move to desktop, all I will do is to say CD, because desktop is a sibling to documents, right? That's where this notation I told you will come in. I'll do a space, right? I will first move to the parent, my home folder first, and from there I will now move to desktop. So to move one step backwards to your home folder, you do a CD and space dot dot. If I use CD dot means, right? Okay, so dot, what it means is this present location. Okay, that's what dot means. So dot dot means the parent location, of where I am right now. So if I say dot dot, it means go back to one step, to the parent location of where I am right now. So take me back to my parent location, my father, where I came, from where you accessed me. So if I have folder A and I open folder A, B inside folder A, and I double click on folder B. So now I'm in folder B. If I want to come back to folder A, I will now say CD space dot dot. That takes me to folder A. So if I hit that, you see that I'm back to my home. But if I want to go to desktop, I don't want to come home and then go to desktop. So now, right, if I want to go to desktop from my home here, I will now say CD space desktop, because desktop is inside my home. I don't need to put any forward slash. So I hit enter, I'm in desktop. So now look at so understanding these two commands, I told you the philosophy of Linux. Now, if I am here at these documents and I want to move automatically to desktop, I will combine this command, right, with where I want to get to. Where I want to get to is /desktop, right? And I'm currently, these two, they are siblings, right? And I'm currently in, let's go back to documents. If you type like the first 3 letters or whatever of that command or that place, you can just hold it, press the tab, and it will complete it for you. So now I'm in my document. So I know that if I do cd dot dot, it will take me back to my home. And I know if I also do cd documents from my home, it will take me to my documents. So I can combine them, right? So I'll say cd space dot dot. That takes me to my home. And then I'll add slash desktop, because my home location, you have desktop inside it. So to show that what you want to access is inside your home location, which in this place, for example, I'll now add my desktop. That's all I need to do. I can remove that last forward slash, it doesn't matter. So what effectively this does is to take me from documents automatically to desktop. I wouldn't need to land at my home folder first before I go to desktop. You see, automatically I'm in desktop. I've combined 2 commands. So I'm just showing you what dot means. Okay, let ls our desktop. There's nothing there. Clear the screen. If I want to create a folder, a file, right? The command to use is touch. I want to create a file. Linux accepts any file extension, be it PDF, anything, it will take it. So let's look at a Word document, right? Let's say touch, let's say text.doc or docx, that's dot, Microsoft Word document, it will take it. What I have done here, touch means create a file with this extension, with the name and extension. If I hit enter, you'll see that this desktop will now have that file and a name. Let's do ls first. Nothing is there. So let's touch. The name, touch space, name, dot, the extension, file extension. We can say TXT, we can say PDF, we can say JPEG, anything, it will take it. But this time we want to use Microsoft Word. So we hit enter. If I run my ls again, you see that I have the file created. But the file is empty. So if so let's leave it at that. If I want to create a directory, a folder inside this desktop, the command I will use is mkdir. So to know what that means, man space mkdir. The name is mkdir and it means make directories, right? Every other thing really doesn't matter here now. I just wanted to show you what the meaning of mkdir. Press Q to quit. Okay, so if I want to make a directory inside my desktop, I'll say mkdir space and the name of the directory. Let's say Linux. It is case sensitive. So whatever you type there, that will be the name. I cannot later search for it with small lowercase letters. And if I hit enter and I do an ls, it will show me now that I have a file as well as a folder. See that? The folder is denoted by its color. You know that this is a folder and this is a file. Okay, so this is how to create a folder. This is, and when you want to create a file, you use touch. That's the command. Okay, now if I want to delete the folder, okay, the command to use is rmdir. And let's check what that means. man, RMDIR. The name is RMDIR and it's remove empty directories. So if the directory has it has stuff inside, there is another way you can remove it, you can delete it. Okay, but at least we know what RMDIR means. So it's an empty directory, so we can remove it with RMDIR space, the name of the directory. And when I run LX again, you won't see it. It's gone. To delete a file, right? All you need to do is to just say rm space and the file name. But now, let's see what rm is. So we type man space rm. So we'll go to the manual. See, remove files or directories. So in this situation, if a directory is not empty, you will not be able to use RMDIR to remove it. But you will be able to use RM to remove the directory. Okay? So, and then there are many options here for you to use. Let's press Q and leave there. So to remove this file, I'll do rm space the file name and hit enter. If I type ls, nothing is there. I've deleted the directory and I've deleted the file. Okay, I have used so many commands lately. If I want to check so far the commands I've used, I'll type history. See, this is what I have been doing also. It's almost like a long list of undo. All these were things I've been using since, right? CD, clear. Clear means to clean up the screen, erase everything, echo, all these were stuff I was doing, right? It gives me a long list, 62 now, okay? So that's how to view previous commands that you've used before. If I want to scroll down to a particular command, maybe I want to make this directory again, use your up arrow in your keyboard. See, as you keep holding it, it takes you to the previous commands, right? We are there, that's remove directory. Let's get to where we make the directory, good. And we can hit enter. We can still create the same file again by going to where we say touch. You just press your up arrow, touch, okay, and we hit enter. And if I ls now, you see that they are back. Both of them are back. Let's clear the screen. ls, they are back. Now, if I want to know exactly where these two files and folder, where they are, I can say print working directory. It will show me exactly where they are. Okay, now, if I want to edit, right, that will bring us to another area, which is the editors, right? Just the way you have Microsoft Word, you have Windows, you have various text editors that you can use. Linux has its own inbuilt. Usually you will have Vim, you have Nano, and all that. But Vim is the most versatile, and it is always, good that you know how to use Vim. Okay, so but before we go there, let me still work on the LS a little bit. If I want to view these files in a structured format, right? Let's do man ls. You see? Oh, sorry, let's There's one option I want to show you. Is the dash L option. So yeah, so this is dash L option. Use a long listing format. See, so let's go back. Now, if I want to view this in a long listing format, I'll do ls space dash L. So it will arrange it in a long listing format. This is a folder. This is the file. It will give you the time, it will give you the date, give you the size, and other information. Okay, so this is how to add an option to a command. Okay, practice. As you practice, you'll get better. Right? It was not easy for me too. So I know it'll be difficult. Maybe one or two people will be feeling overwhelmed. But this is how it is. If you are not used to it, well, once you keep practicing, I'm going to leave you with a comprehensive a drill that you will work on, right? I'll give you a drill on this. So let's move on. We've looked at removing files. We've looked at changing directories from one to the other. Getting to know our location, that's free working directory, listing contents of a directory, that's the ls. Okay, so what if let's ls desktop, we have that text, copy this file to my documents, okay? My documents folder. So what I can do here is to say the command to use is cp space file name space destination path. Okay, so that's the way you structure your command. So cp means copy. So if you want man cp, it will tell you cp means copy files and directories. So you can use it for both, and it will give you various options. You can have many options, as you can copy 2, 3, or 3 files at once. You can use a -t. You can, and it will tell you what that means at the bottom. See, these are various options you can use. I told you when you see the 3 dot, it means you can use multiple options. Okay, yeah. So we'll go to the queue there. Okay, so let's copy these to documents. The first thing we will consider is if I want to copy this to the documents, I will say cp, and if I put a dot here, it means I'm copying it to this same location. There will be no changes. But if I put a dot, it means I'm copying my home, right? I'm taking to the parent location. And in my parent location, let's come to our parent location. I'll clear the screen. I'll ls so that we see all the files. I'll cd back to desktop. Okay, so now I'm in desktop and our LS. So if I just want to bring this before us again, this is in our home location, we have all these folders. We entered the desktop folder. We created a file and a folder inside it. We want to move this file from here to the documents. So the way you will reason it, it means I will come out from here into my home folder, and then from my home folder, I will now go into my documents. So that's the way. So now but here we are inside the desktop. So we'll use our copy command, space. We know now that moving one step higher backwards into your parent folder, you use a dot to as a command, and then we put our forward slash, because inside our home folder is our documents folder. So we represent, we are telling Linux that in our parent folder, there is a file inside it, folder inside it, and that folder is documents. So this command tells us that we are going to copy something to our documents. But what I'm copying, to press your back button to come back. After CP, you put space and the name of what you want to copy the file. So in this case, our text file. If I want to copy a second file, after this one, I'll put a space. And for example, I want to copy the folder Linux, space, and I'll type the folder, right? And that's it. And I leave space, and I will now put the location where I want the destination, where I want them to go, right? Copy this file, space, this folder, space, to this location, right? So that's what I want to do. But let's start with the file. So I remove this. And when I hit enter, you will see that if I go to the documents, right, I've effectively done a copy of this, right? You will need, what I'm teaching you now, you will need it in scripting, right? When you start combining commands to run scripts, okay? And immediately we do this, if I cd now, using this same understanding to my documents, space, dots, / documents. Immediately I go to my documents and I do ls. You will see that there is that file that I've copied. It was in desktop. I made a copy and put that copy here. Okay, so you have it both in desktop and documents. Okay, I want to copy from documents to maybe downloads, the same principle. CP, go back to my original location, my home location, which is one step backwards in this situation, right? / put the downloads, because that's where I want to bring it to. And once you do this, right, if I want to copy everything in documents, maybe I have 200 files. After I do my CP space, I'll just put dot space, because that means everything in this location. I told you dot means this present location. So copy everything in this location to this place. But I don't want to do that yet. We know the file we want to copy. So copy that one to downloads, all right? Once you put the copy sign command, space, the name of the file you want to copy, space, and then you now put the destination, which is in my home folder, go to downloads and paste it there. So if I move to my my downloads, which is cd space, use the same command, / downloads, I've moved to my downloads. If I do an ls, I am there. And you see that the same file is in 3 locations. If I want to remove it from downloads, all the commands I've told you now, I'll do rm space and the file name. And that's gone. ls, it's not there anymore. Let's cd to my documents, // documents, ls, check. The file is in my documents. I deleted it from the downloads. Let's delete it from documents also. Remove, space, the same file, and enter. If you do an ls, it's no longer there. Let's cd, change directory to our desktop. If I ls, I have the file there. Okay, so we are back to, let's clear the screen, we're back to our original location. So that's how to use commands to achieve results. If I want to completely move the file, not copy, right? I want to cut and paste in Windows, right? You will use the command mv, and that will move it completely. So if I say man mv, move or rename, so I can rename it in that very location, or I can move it to another location. So if I say I want to change this text, maybe I made a mistake, it's supposed to be texts, but I use text, so I need to change it to texts. I will move it in this present location. I'll just say mv space, the name of the file, and the new name. Okay, so what will be the new name now? This, use my arrow to come back, and that's put an S there. So what I am saying here is cut this file or rename this file as this. That's all I'm saying here. So this is all happening in the same location. We're not moving it to another location. We're just renaming it. So you use the move command to do that, right? In this, I hit enter, and I do an have an S. See, I just renamed it. But let's say I want to move it to documents. What I would do is to say move the name of the file and then the location. Remember how we did copy? We move to our parent folder, we do a / and the location you want, documents. That's all. It doesn't matter if there's a / there or not, to go there. So right now, what we're saying is cut this file from desktop, move it to documents. If we hit enter, and we'll do an ls, we're in desktop, you will not see anything. It's no longer there. If we cd space, change directory to documents, change the directory space, go back to our parent directory, / documents, hit enter, we're in documents. If we do an ls, we check, the file is there. We can move it back to desktop. Same principle, move space, the name of a file, right, and then the location. Go back to our home directory, / and then where we want it to be, desktop. Hit enter. If we ls in documents now, it's no longer there. cd, go back to our parent directory, / to desktop to look whether the file is there. We're in desktop now. ls, the file is there. We want to change it back to text, the original text. All we need to do is to move this present name, right, to text dot x. If we even put JPEG, it will change it to this. Whatever you put there, is that flexible? Okay, we'll just want to change it. Okay, and then when we do ls now, we've changed it back to the original. So you can do all these things using Linux, little commands here and there to achieve big things. This is just the philosophy. I clear the screen, I CD back to my parent location, right? I mean, this dot means the parent of this one, the immediate parent. If I don't put a dot, I'm going straight to the home location completely. So, for example, let's do an ls here. There is a folder called Linux. If I cd to this Linux, I mean, desktop, Linux, you see, it has changed. It tells you I'm here. The last one is usually where you are, right? So if I do print working directory, see, I'm in desktop, come straight to my home. I'll just do cd and nothing else. Linux back to desktop, the parent, I'll do a space and dot. That will not take me straight to home. It will take me, it will stop me here. See, I'm back at desktop. You see that? So that's how to move, use CD and dots to move. So I will stop here and take questions. This is just an introduction, okay? We will go further when we meet and look at other ways to edit files, write inside the files, check, see what's inside the files, and all that. Okay, so I will enable you for comments and also your videos. I've enabled your microphones. And one who wants to comment, you can, and let me hear you. Before you do that, you guys are not, this is free. I'm not charging anybody. The best you can do for me is to just make favorable comments. I mean, on my YouTube video, right? And subscribe, tell people about something happening free, and let them come and join, right? It's free. I mean, just do that. It doesn't cost anything. I'm not asking you to pay any money. I'm spending my resources, a lot of money I'm spending on my own. Okay, so I'm not asking you for anything in return, but just to do something that's free. Okay, so all right, so let's hear from you guys. If you are new, you are already used to Linux and all that, you can contribute. You can, say something about, teach people, tell people what you know in certain areas. Let's learn. Okay. Andy, thank you very much. So for you to know, this session is officially ended. So we'll stop the recording, but I mean, we can contribute and, let me hear from you what you think, what you want, what ideas you have. Let me hear you. Yeah, Andy, go ahead.
Yeah, thank you very much, sir, for this. It was a really lengthy and, as you said, overwhelming section, but some of us are new to Linux, so it's kind of new to us.
All right. Okay. So welcome, guys. Today, as you can see, we are going to be looking at process and performance management. I hope you guys are practicing, I hope you're like checking stuff, doing researches and all that, because it will help you make progress fast. What I'm going to show is not enough. What determines how much you will grow is your determination to practice, studying, labs, and handling projects, not giving up, not quitting, looking for solutions, you know, so stuff like that, being dogged, being resilient, that's what will make you, a cloud engineer or a DevOps engineer, because what I just described is what we call a problem solving, someone who is always thinking he can do it. Set. So, as a cloud engineer, as a DevOps engineer, your job primarily is to solve problems. And the best thing you can do now is to start getting used to solving problems by engaging and trying to counter as we move on. Yeah, so today, as you see on the screen, we'll be handling management in Linux. So, in your possibly, you could even be a Linux administrator. Let's just use that as an example, or a cloud engineer, and your job may be just to monitor CPU usage, right, of the to check who is to check system information, right, to check the software
release, things like that. You know, just the way in your Windows, when your hard drive is getting full, or you probably just click the hard drive, you right click, you go to properties, and you see your the size of or your Windows is malfunctioning, and then you check, you go to your systems full app, you check and you see that there are new releases, security releases, right? New uh, updates that you need to do to make your operating system run well. So think of it that way. So that's what happens when you're using Ubuntu. For example, your processor may be overloaded. Your processor may be, properly utilized. Your memory may be full or, adequate, just good. Or you may be using too much memory, you know, or your storage may be close to full. Or you want to find out who is working in using this system today. You have team members working over the world from different locations, and you want to check who has logged in, right? You want to even see the information of the computer itself that you're using, right? Or the software release of what you're using, right? You want to check for something like the IP address, of the system, things like that that you want to look at, right? So that's why we're looking at um, this topic of process and um, performance management, right? That's why we're looking at it. So the last time we looked at file permissions and how to address permissions in files. The one thing I want you to understand is I gave you a small drill to do on commands. I hope you did it. I hope you tried to do it, because at that time I had not told you about file permissions. So I'm sure if you had done it, you would have come across maybe the challenge of trying to attend to some of the numbers of what I told you to do. But if you're already good in Linux, it's something that you're used to, then you may not have any challenge, right? So I just wanted to mention that so that we will not take for granted of these apps that you are given to do. Okay, so quickly, let's jump into the session today. Now, let's look at the monitoring CPU. Okay, so the first thing you want to do if you want to monitor your CPU, right, is to use the command top. There are other commands, right? If you use the command top, right, and you hit enter, it will give you a it will give you a good like detailed information, right, on your CPU status and all that. So here we have top, and I hit enter, and we come to this environment. So I will just look quickly about, I'll talk to you about these things that are changing now and then we'll come on top to look at uh, each of these, some of the elements here. Okay, so this is called identity, right? Process identity. Usually, the first thing that comes on when you turn on your uh, operating system is called System D. It is the most important. That's why it's assigned the process ID 1. Every other thing has other process IDs, but this one is assigned process ID 1. And in order of importance, right, they continue. Okay, so you have thousands of processes. These are all called processes. And whatever is running here is called a daemon, right? So quit, you press Q to quit or clear the screen. What you just saw running in the background there are called daemons, right? And they are automated processes that run in the background. Right? They make the system work, right? Efficiently. So they make the system work efficiently. The system works clearly well because of these daemons, which are processes that run in the background and make everything work seamlessly. Okay? So if I type top again, we go back there, you see that these are all daemons, right? They are processes that run, and it goes down and down and down, right? So now, if you notice, you'll see that there is a percentage of CPU that each of these processes use. Are you seeing that? They are actually using percentages of CPU, but it is very insignificant. That's why you're seeing 0.0. You'll also notice percentage of memory, right? It's also showing 0.0 because we're just logged into the computer. We're not really doing anything, right? And then when it comes to the system D, you will see the time in which it's been running, right? You see that it carries time. They carry time, in which they've been actively working. The top command, the first thing you will see here is the time, right? 22 hours, 18 minutes, 32 seconds, right? And that's the time. And then you will see up. What it means that this server has been up for 42 minutes. So it's been running for 42 minutes, right? And there is just one user. I'm the only one using this server at the moment. Okay? I'm the only one using it at the moment. And if you look at the load average, you would see that this load average is divided into 3 areas. Okay? We will look at that when we do what we call load testing. Or stressing, right? Where we stress the computer so that just to check
certain things when we get into the cloud, AWS, and we start looking at auto scaling, the concept of auto, a particular that the memory and the CPU are overloaded, and then it will trigger the auto scaling mechanism to create new servers automatically so that the server that is being stressed will not crash, right? That's when we will see where this average load comes in. It actually captures the average load every I think 5 or 15 minutes. So what you see here will be the average load in the last 15 minutes. Then after another 15 minutes, 30 minutes after, which will be 30 minutes after, it will capture a new one. Then the old one here will move here. Then another 15 minutes, that will be 45 minutes after, it will capture a new one. The one here will move here. The one here will move here. So you'll see an average load, right, in 15 minutes interval. Then tasks. When you come to tasks, you will see that all these things we're looking at, the processes, are all tasks. We have 103, right, in total that are running. There are more of them, but we have 103 that are presently running. Okay. Sorry, the tasks that are present is running is just one. Okay, so we have 102 sleeping. Okay, so they are not really doing anything. Just one of them is currently active, right? So I have not stopped any task, and there's what we call a zombie task. Okay, let me quit to explain that. Play the screen. A zombie task. Maybe how do I explain this? Okay, let's explain first. So these daemons, what they do is they start a process, they start a task, they they cycle in the task, right? They are copied into the memory, right? And then the CPU accesses them and runs the command or the process that they carry within themselves. So it runs, and once that task is completed, it is let go, right, from the memory. And when the time comes where it needs to run again, it will be copied back and it will run. But a zombie task is a daemon that has gone, let me say, not exactly correct, but for you to understand, has gone rogue, where the task refuses to end. It just keeps behaving, it's almost like when your system freezes. You understand? So you can't do anything about it. So that task has to be killed, has to be stopped one way or the other. You can kill it. Okay, so that's what we mean by a zombie task. Okay, so I hit my top and I come back again. So there are no zombie tasks, right? And then we come to CPU, okay, or CPUs, which means you can have more than one, right? And the one currently in use, right, by the user, by me, is just 0 point something percent. It keeps changing anyway. While for the system itself, basically we're almost using nothing. The CPU is not carrying out any major commands, any tasks. Okay, right? And right now, this is what is idle, right? When you say ID, means the idle percentage of the CPU that is idle. 100% is idle, which means the CPU is not really being used to do any computation. If we stress this computer, you see that this thing may drop to 50 or 40%, or, so you know that that's what is maybe 40% of your CPU is idle. The other 60% is being used. Okay, so we come to the memory. I'll leave all these ones. We'll come to the memory. You see that we have 70957.4, in total, gigabytes, or is it MB in total. And if you look at, you see that you have the number of memory that is free is 240, that we're using currently is 306, right? The one that is in like in your cache, things that are running in the background that you've not shut down and all that, right? That are available to reload. You have 561. So this is how you look at your memory. Most importantly, these two, you look at them, because when you start having very little free memory, then it's a problem. Like you see here now, the memory that is free is not really much. Okay. Okay, so this is, I just want to explain the command and what you're seeing around here in the command. Okay, so that's for the top. Okay, we're going to move on to another, the same kind of command. I'll press Q to quit. I'll clear the screen and I'll say hit top. Now it's the same kind of environment, but it's a more, it's a little, if you look here, you see that the CPU is barely being zero. Now it's gone to 0.7%. While your memory, you see that you are using 149. Remember, we saw the total before. Okay, and the load average shows up here also. We're seeing the load average, but we really don't have any load, right? We have this gives you like a more graphical feel, right? You still have your process IDs, right? And yeah, basically. Okay, so I just wanted to show you, it's basically the same thing. At the bottom here, you have some commands. It's almost like in your Windows, it's almost like when you get to your when you go to your BIOS setup settings area, right? You see various commands, sometimes at the top or at the bottom, for you to quit, for you to do this, to save and all that. So yeah, here you can use your keyboards. F1 for help, F2 for setup, for search, F3 for filter, for tree to see how they are all connected, to sort for any particular one, and all that. To kill, which means to stop completely a process, and to quit, F10. You can also just press Q and it will also quit. Okay, so now so let's continue. Let's continue.
we've looked at two now. We've looked at, in fact, one. And that one, we use two different commands to check compute resources, which is the memory, the and the processor, the CPU, right? And that you can use top or H top. They'll still give you the same thing. Okay. So if someone tells you, please, can you check a particular server, check the memory stage or CPU stage, you just when you log into that server, you just go top and you'll be able to see that and you'll be able to report, okay, I can see that this is what's happening here and all that. Okay. So another thing I want to know, this server, the host name of the server, right? The command I will use is host name. Enter, it shows you the name. The name of this computer currently is being represented by the IP address. We'll talk about when we look at networking, we're going to be looking at IP addresses and how they are structured. Okay, but this is the host name. And with this, you can identify the computer probably in the cloud. This is actually a server running in AWS Cloud, an EC2 that I am running right now. Okay. If I want to check system information, such as like the kernel, I told you what the kernel is. Okay. Those are that background processes that are running that interact with the hardware, right? Those are all those daemons that are running at the background. That's what we call the kernel, right? So if I want to see the kernel version and all that, we're looking, remember we're looking at system monitoring and processes. Okay, you can use this command, uname space dash a, and when you hit enter, it's going to give you the IP address, right? To give you the version of the, this one has to do with AWS, right? And it's going to give you the time that at which, this is not the time I logged in anyway, right? It's going to give you the date, it's going to give you the architecture, of the system x86, give you the underlying technology, of this operating system. When we looked at Linux at the beginning, we said Richard Stallman was the one who started the GNU project, and Linux was, and GNU means GNU is not Unix. And then Linux, which was now built by Linus Torvalds in the early 90s, now incorporated almost all the commands of GNU. You will understand why this GNU is there, right? So this is how to display system information. Almost like when you go on Windows, you right click, see your system, and then you go to the properties, and it will now see all the information of your system. In the command line in Ubuntu Linux, all you need to do is to type uname space dash a. Okay. Okay. Let's say you want to find the particular release, right, of this Ubuntu, which is a Debian distribution, right? You want to see the specific release information. You can say lsb underscore release, right, space dash a, right? So it will show you, he says no LSB models are available, but then it will show you the distribution, right? Info, Ubuntu, the ID, Ubuntu, the description is the 24.04 LTS, which is the one I said we should install in VirtualBox, and then the release, that's it, and the code name, Noble. Okay, so these are just internal stuff that are put there by the producers, those who developed it. This is how to, can I know this is using 20.04 or this or that, right? You can easily just do that. Remember, check the system information. We didn't see this release name. We didn't see those stuff. We only just saw that it was Ubuntu. But we didn't see and we saw the system specification. This one has to do with the hardware bare metal, right? The configuration of your computer itself, where you are getting this virtual computer from, right? It's an x86 and a 64-bit architecture. But when you want to look at the software and you want to check the release, like Windows 10, Windows 11, Mac, Catalina, and all those various Mac releases, this is how you do it in Ubuntu. LSB underscore release space dash A. I hope we are following so far, so that I can know and okay, Tommy Day, right? Good. Yeah, Drew, I can see that. I can see that. Okay, Itopa, you raised a hand. Okay, let's see. Let me give you permission if you want to speak. Just so Itopa, are you ready? You can unmute yourself.
Yes, sir. I'm following. Thank you so much, sir. And I'm also quick feedback. You're doing a very great job. You're taking your time. You're breaking it down, and it's really, really interesting.
I can't hear you. Can anybody hear him? Or her?
Yeah, I can hear you.
Can you hear me now, sir?
Oh, I can't. Why can't I hear?
We can hear him, but I think we can't hear the tutor. It happened yesterday.
Probably because we are still sharing. That's why you couldn't hear him.
Okay, well, I'm surprised I can't. Why am I not able to hear? So, well,
maybe because you are still sharing your screen.
External speakers, wait. Okay, can you speak again?
Hello, can you hear me now? Hello.
Perfect. I can hear you now.
Oh yes, I was giving a quick feedback that thank you for the amazing job that you are doing. That it's very clear, very understandable. And I'm saying, please, what's the main difference between htop and top command?
It's just the graphics.
Oh, okay.
If you look at top, that there are no graphics. It's just data. Well, htop has some small graphics just to beautify it. That's just all, nothing else.
Okay, thank you.
One question, please. The command to kill the process again. Can you just do a quick recap of that?
The command to kill the process?
Yes, to reduce memory. Because I come across this in once in a while in my workplace. When we have high CPU utilization, the memory is kind of high. And I always remember, I always go through this same top process.
to try to free the memory a little bit. I get confused a little bit on that, so that's why I just want you to recap that side.
Okay, you just use the command kill and then press ID. Again, what will be the best solution whenever you run into that kind of situation? What I can tell you is there might not be auto scaling going on. So, because if there is auto scaling, it will immediately and automatically it will drop the old server that is getting loaded up, whose memory is getting loaded up will reduce, right? And the load will now be shared. Let's say you just have one server. A second server will come up immediately once the memory gets to a initial, let's say 50%. Once it crosses that, an alarm will trigger and a new CPU will be spun up, and then the load will now be shared by both, all in a bid to keep that memory usage below your threshold. So I feel something is not just right, except you're not explaining it clearly. That
It's not in the cloud. It's more on the device itself. So the device, the system is old. So that's why the memories are full, and we are in the process of decommissioning them and upgrading to a new system entirely. So for now, the only workaround is freeing the memory a little bit, like kill some process. I know there's a particular process we they always specify, but it's in our document, the workaround document. Yo, okay, kill PID. Okay.
That's you when you kill, then the PID number.
So I replace the PID number
to process you want. So let's just go, let's say pop, right? So this is the PID. I want to kill system D, right? I'll just say key, or I want to do one process. Oh, well, if I leave here, I would have killed it anyway, right? So I'll do kill space 1. So it means I'm killing system D, right? So that's it. This top is a process that's running.
Okay, so you don't have to use PID.
That process.
You don't have to put the PID in.
No PID. I just use days. No. So I use this so that you know that. So this is a command. Kill, for example, if it is a system D1, it knows that system is killing. Okay, so
thank you.
I'll put you guys again on mute. When you guys have any questions, just write and make a comment, and I will look at it, and and then we'll know how to move. Okay, so I stopped at explaining the release LSB_release -A, and to show you that this is the particular version that of the operating system, while the other command that we used, right, which is uname, will show you the hardware configuration, the information of the architecture, right, of the hardware. See, so that's just the difference. So these are, commands that you have to just take note of, if you are probably in a, Linux administration, you can't tell where you will excel. Okay, let's say the system is running for so long. I want to find out how long it's been running, right? All I need to do is to type up time, and it will tell me, right? It's been up for over an hour, one use the load, almost nothing, right? And the current time, that's the current time here, okay, at the time I ran this command, okay? So that's for you to know how long the system has been running. This is the actual time the system has been, okay? So now, if we want to check memory, right, in a human readable format, you know, we can do free space dash H. You see that our memory, we saw this one in top anyway, right? But it will give us, it will just like filter out, slice out just the memory information for us, right? You see your total memory, your used, your free, and all the other information. Okay, so if I want to look at maybe my disk space storage, right? I can say df space dash h. And all my disks that are running and where they are mounted on, right? In my Linux, show me where they are mounted on, how many percentage is in use. This one now is being, and two are coming from the cloud, my cloud storage, right? And you know, they are, I'm using 10 and 6% of one of them. Okay, so this command helps you see all your storage, not memory, not RAM, your storage. Okay, so now if I say du space dash h, I'll be able to see the disk usage of files and directory in a human readable format. I'm seeing 8 kilobytes, right? 4 kilobytes, 16 kilobytes, and the different usage. This one was used by HTOP, right? And other processes, right? And 16 kilobytes on sh and all that, you know. So some of these things might not be relevant, but it's good for you to know. You can't tell where they will just ask you in an interview, I want to see disk usage and files stuff that is being used, it will be more. But because this server is completely empty, there's nothing going on. I just launched it to do this training. Okay. And of course, I will pay for it, you know. So let's see another one, PS space aux. You see all those processes that we were looking in real time, right? This time it just takes like a snapshot of them to us. A snapshot of all the processes and gives it to us. So this is it basically. So another, okay, I've told you about the kill. Okay. So if you want to shut the zoom down, right? You can use the command kill all process underscore the name, right, of the process, right? So it will shut it down. But most times we hardly get to that kind of point. Okay, so you want to shut down the system. Well,
These are all system processes, commands for system processes. You want to shut down the system, you sudo shut down space, that's H, enter, it will shut down the system immediately. Okay, I don't want to shut it down. Okay, if I want to reboot the system, I'll do sudo space reboot. Right? And the system will reboot. Some of these commands, you can put them in your own program. You can actually put these commands to do stuff. When I install these, maybe during your installation process, you know, you remember we installed applications, some applications in Windows or in Mac, it